Good day, team. This video is an end-to-end demo on Sanatio, in which I will show you the functionalities we have built in Sanatio so far, which will be included in the frontier as well in the future. So, model validation is a crucial part in the life cycle of a model, and it is an estimate of how well it is going to perform in the real world. So, Sanatio exactly does that. Sanatio has a validation routine class in which the necessary parameters like the prediction, the actual value, the weight of the model, and the predicted probability if it was a classification based model, and some optional parameters like Pearson threshold and VF factor could also be given. So once those parameters are given to the constructor, and when the respective routine is called, Sanatio prints a markdown file, and it not just prints the markdown file in the notebook, but it also saves the markdown file in the local system with the respective date, so that it acts as a log file for your model development process, and it will be useful in the future as well. So it is divided into four phases, in which the first phase will have the nature of the data, and it checks the sparsity, correlation, and recommends certain columns to be removed, and so on. And the next one is the phase two, which is model validation, which has the necessary arguments we use like the accuracy, precision, which are useful in finding out how the model is performing. And the third phase is prediction analysis, which is useful to the user in the process of feature selection, in which each feature's contribution will be shown, and the user could select the top seven features or so on, and the user could build a model from that. And the next phase is the visualization, in which all the visualization details will be given, and what the visualization is essentially showing. And not just it prints the visualization in the notebook, it also prints how an ideal visualization looks. So the user gets an idea of how their model is performing, and whether it's performing worse or performing better, as they have a model in the right side of their plot. And let's say Snatio gives us a lot of recommendation, and we want to implement those recommendations. So Snatio also has a function, Enact function, which is again a class, and the necessary training and testing data frame and the model should be passed through to that class. And when the respective Enact function is called, so Snatio again does what is it prints a report, and it stores the report in the same manner, and it essentially shows what are the changes that have been done by Sanatio, and is there any change in the metrics. So the user could just look at the metrics and understand whether the model is improving or not. And the user could also change the optional parameters like the VIF value and the Pearson threshold, and look how the model is changing. So the user could also do that, and in those optional parameters the user gets a lot of flexibility. And in the visualization part, it shows the before after images to essentially give user an idea of how well the model is performing. And let's say if the user wants to build a model, but it doesn't need to be the same model that they have trained on, but it should give a good accuracy. We could always use Sanatio's AutoML functions, which is again a class, and the necessary training and testing data frame, and whether it's a classification or regression should be given. And once it is given, AutoML classification model will be built upon the data that the user passes, and model is built upon grid searching a lot of parameters by using sklearn's AutoML package. And once model gets completed, it generates a validation report for that model, for the AutoML model that was trained, and it also returns an AutoML object in which the user could see what was the model that was trained and what has the different values, and all the functionalities that sklearn has in with it. Yep, thank you.